So, welcome to the post-class video for dimensional analysis and problem solving. And it seemed like the class did pretty well with conversion factors and simple dimensional analysis. And so what I thought we would do today is just go through perhaps a slightly more complicated problem solving. And we'll use the COAST method. So here's the problem that we're going to start off with. Stainless steel cylindrical rod has a density of 7.55 grams per centimeter cubed and a diameter of 1 inch. How long of a piece do we need to cut off to make a 1 kilogram piece? The volume formula for the volume of the cylinder is V equals pi r squared h. Right, so we're going to use the COAST method, and the C stands for collect. So what kind of information do we need to collect for this problem?
Well, let's start by collecting the numbers. So we know that the density is 7.55 grams per centimeters cubed. We also know that the diameter is 1 inch. We know that we want a mass of 1 kilogram. And the formula over there.
And the formula. Okay, and so which part of that is our answer? Which part of that is our starting point?
Well, I think we want to start with the mass, because that's actually what we're looking for.
Yeah, so we're given a mass, that's kind of our starting point. What are kind of the other things that we are going to need to do? Let's look at the units. So we have grams and centimeters cubed and inches. So what are we going to have to do with the grams and the kilograms?
We're going to have to convert that so that they're in the same units.
Okay, so that's part of our organizing. We're going to have to go kilograms to grams. How about the inches?
Well, we're going to have to convert the inches to centimeters so that we can actually use that in the density.
So we're going to inches to centimeters. And so we need a conversion factor for both of those. Do you know off the top of your head what the conversion factor for inches to centimeters is?
Absolutely not.
Okay, so where are we going to find that? On the back of the periodic table that we handed out in class, there's conversion factors, you know that. You can find them in the back of textbooks. You could also find them usually on the internet. Just type in conversion factors and you'll probably get lots of tools for that. I happen to know that the conversion factor between inches and centimeters is 1 inch equals 2.54 centimeters. And then also kilograms to grams, 1 kilogram equals 1,000 grams. That's kind of the collect and organize part. Analyze. Okay, I want to end up with a length, right? So let's say I want to end up at centimeters.
Okay.
I haven't used this equation for volume. How are we going to use this? Volume pi r squared h. Are there any volumes on there?
There's a volume here, centimeters cubed.
Okay, volume there, centimeters cubed. What do you think that h corresponds to? If we think about this as the cylinder, well, the diameter is how far across it is. What is the h going to correspond to?
The h would correspond to how long it is.
Okay.
Right? The height.
Right. Isn't that what we're trying to find out? We're trying to find out how long a piece we need. So that's going to be the height. So I can take this, and what I want to find, is the height. Stay on the white part, Joel. So one of the things I know I'm going to have to do is rearrange that. I'm going to have to solve that equation for height. Height, and I'm sure you can all do this algebra. It's pretty simple. Equals V over pi r squared. So I need to find r and I need to find v in order to calculate this. What about r? How do we get r?
Well, if r is the radius, then it's half the diameter.
Okay, so that's going to be 1/2 the diameter, which equals 1/2 of 1 inch. And so I'm going to need to convert that to centimeters, right? Because we want our answer in centimeters. And so there are lots of different pieces of this problem. The last piece is, how are we going to get this volume? What is volume related to up here?
Volume is related to the density, right?
Yep.
So we can actually use the mass to solve for the volume. if we have
Okay.
density.
So density equals mass divided by a volume. That's the definition of density. And so if we want volume, I can rearrange that and say V equals mass divided by D, density. Right? So I can solve for all these separately. So I think we have a plan now. I'm going to calculate the volume to put into this equation. I'm going to calculate R to put into this equation. V equals mass. What mass I'm going to use? I'm going to use
You're going to use 1,000 grams.
1,000 grams. Right? We kind of did that conversion just by knowing that 1 kilogram is 1,000 grams. And the density, 7.55 grams per centimeter cubed. And so that allows us to calculate that. Now, the R I get from our diameter. So the diameter is 1 inch. The radius is 1/2 of that. And then I need the conversion factor of inches to centimeters. Right? So I want my conversion factor here. Which one goes on top, which one on the bottom?
You want the inches to cancel, so you're going to put the inches on the bottom. And you want centimeters in your answer, so put those centimeters on the top.
2.54 centimeters. The inches cancel, and I should be able to calculate a radius there. 1.27 centimeters. Wow. So I can put this all together and say H equals 129 centimeters cubed.
Okay.
And so now I can plug that into this equation, 129 centimeters cubed over over pi times 1.27 centimeters squared, right? And I have to square the number as well as the units, and that'll allow me to calculate H, which if you plug that into your calculator, you get 25.5 centimeters. Right, so a lot of different steps. But if you break it down one at a time, you can get there. And you don't always have to know where you're going. You don't always have to see the path from the beginning all the way to the end. Like, if I want to get to New York City from here, I don't know how to get there, but I know that I better start going east. So I get on Highway 26, I follow signs to Portland, I keep going farther and farther east, and eventually I'm going to get to New York, right? I don't have to know the whole path in order to follow the path. Right, Neil?
Sure.
So thanks for watching, and we'll see you next time.